Hello everyone, welcome back to my Let's Code tutorial. In the last part we dealt with the bool values being true or false, as well as arrays. For example, our array that we called name. In this part I'll be going through a very important topic. It's called loops. There's 3 different kinds of loops, and in this video we'll touch on all of them. If you're going to be programming in C++, loops are pretty much a must, because if you don't use loops, then you're probably just going to have to really just write so much code that programming doesn't even become fun anymore. So, for this time, I'll first explain the main reason you'll be using loops. The main reason you'll be using loops is for array management. So, for example, the reason we'd use an array, like name, is that if we had more than 4, let's say we had 1,000 names. As you can see, this 1,000 times down would get very tedious, writing every single number from 0 to 999. So we have a much better way. I'm just going to turn this down to 10, and we're going to get rid of this. Our first kind of loop, it's called a count controlled loop. Basically, a count-controlled loop it's a loop where you know how many times it's going to go around. So an example of this would be a game of Dizzy Bat. At least a game of Dizzy Bat with a set amount of spins. So you run to one side, put your head against the bat, and rotate around the bat 10 times. That would be kind of like this. We have a event controlled loop. This is basically you just keep iterating until something happens. An example of this would be kind of like in your cookbooks. You'll have a recipe that says beat the eggs until they are a kind of like a creamy texture. You won't really see kind of a count-controlled loop in a cookbook. I mean, come on. Just imagine. Beat the eggs 151 times and then put it with the flour. No, that just doesn't work. But that's event-controlled. Keep looping until something happens. And then we've got a flag loop. Flag loops, kind of like event-controlled. Basically, you just keep looping until the flag is set off. Okay? So, our first one, we're going to go through the count-controlled loop. So, we want to input people's names. So, there's a couple ways of doing this. Count-controlled, you can use a while loop, and pretty much all the loops can utilize while. Inside here, you will have the condition. Up here, we're going to need a counter to count how many iterations. So we're going to go int iteration, and spelling doesn't count. We will initialize that to 0. And down here we will use iteration. Well, iteration is less than 10 because we want every single number from 0 to 9. So I'll explain this in a bit. Well, iteration is less than 10. See in name iteration. So what this is going to do is iteration will loop through every single number. Oh, I got to add one more thing. Iteration plus plus. So what this loop does is it comes in with iteration being 0. It enters this. 0, which is iteration, is less than 10. So it enters these curly brackets. And you enter in a name for the array called name at position of iteration, which in this case is 0. After this, we execute this command. That command is the same as saying iteration is equal to iteration plus 1. So this is just incrementing it by 1. You can change this up a bit. So plus 2. Oops, I think I made a mistake here. Seem to have forgotten that, but no matter. You won't really need to use like 2 or any other number because you're going to be iterating 1 every time. So we add 1 to 0, which is now 1. So the number 1 is stored in iteration. We end this loop and go back to this while condition. So while iteration, which is now 1, because we incremented it, is less than 10. 1 is less than 10, so this statement's true. We go into this block of code, and we do it again. We do it all the way up until iteration is equal to 9. When iteration is equal to 9, well, we check it again. Iteration, it's going to be 9. Less than 10, that's true. So we go in here, we do this for name at position 9. Then we increment it. So 9 plus 1, 10. We go up here, while iteration, which has ended up as 10, is less than 10. 10 is not less than 10. 10 is equal to 10. So this statement is false. As soon as this becomes false, we jump over this block of code. Okay? So let's give that a shot. So, what is your name? Oops. What is your name? Tom, Dick, Harry, Sally, Ned, Homer. I don't even know why I'm doing Simpsons characters. Let's see, what's another one? Tom. It really doesn't matter at this point. Blah, blah, blah. That's a name. We need another name. Moby. How many names do we still have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more. We're going to call it Numpton. So whose name do you want to hear? We're going to hear the person in number 7. So this is 10, 9, 8, 7. So we should hear Tom. Oh, there's a slight mistake here. And that's because we've been screwing around here. We don't need these bools right now. So we can get rid of that. And now it'll work perfectly fine. If you don't believe me, pause the video, try it out for yourself. Okay, welcome back. Now this is a good loop. It's the same as everything else, but for count controlled, you can both do a while loop as well as a for loop. For loops are special only to count controlled loops. Here's how they work. We essentially replace the while with the word for. Now inside here, we don't need to be doing stuff like this here and this here. So for int, and what most people do is they'll have some kind of just one letter variable like I. For I equals 0. I is less than 10. I plus plus. So all your information is in this first line for the loop. This makes it very easy to keep all your data kind of localized, because if we had the integer kind of out floating around the entire program, one, that gives us the potential of changing it and screwing up our program. Oops, we need to get rid of this. Screwing it up and, ballsing our program up. Or, well, it's not, or it's just more efficient like that. Basically, every single variable gets erased as soon as it leaves its kind of zone of control. I'll go over kind of the zones later, but for now, all you need to know is this is a more widespread used method. It's more efficient, it's less prone to errors, and it's just all around better. Try using for loops for the count controlled stuff. Okay, so now we've got this count control loop. Now we need an event controlled. So we're going to kind of make a different loop in here. So we'll go while name person is not equivalent to Tom, and we're gonna do this again. So what this loop does is it asks you first for a name, and in these event control loops, this section just before, it's the priming section. You must have at least one iteration before you do this while thing. Otherwise, there's just nothing to go inside the condition box, and it will just jump over and screw up your program. So this asks us to pick a person in the name array, and then if this person in the name array is not Tom, then we're just going to keep asking until they give us a person whose name is Tom. Now, obviously, this is a bad model, but for this round, this will work because we're going to actually put a few Toms in here. Tom. Blah. Yeah, as you can see, I'm just not. Okay, so whose name do we want to hear? Let's hear number 6. Whose name do we want to hear? 5. Whose name do we want to hear? 9. Whose name do we want to hear? 3. Well, that's Tom. Tom's a good name. Everyone else's name in this array sucks. But that's pretty much how the event control works. You come up with some sort of a statement, pretty much like what you would put in an if statement, except in this case, if the statement is true, then you just keep doing the block of code within, as opposed to if that just does it once. The last one, flag loop. I'll touch on that today, but I won't really get into it too much, because where you'll be using flag loops is mostly for when you're inputting and outputting from files. So let's just see here if I can do this. First things first, we're just going to get rid of all of this stuff. Just throw it into a comment just in case I want to use it later. And I'm going to show you the one last kind of loops. They're called do whiles. So do while. This is essentially exactly the same as a while loop, except the while is at the bottom. So we're going to just create a char or character x. So cin x. So while x is not equivalent to 0. Now, for characters, you'll want to use the kind of single quotation marks as opposed to the double quotation marks. Single quotation marks, they signify one character. Double quotation marks signify a number of characters, a name, a sentence, anything with more than one character inside. The difference between a while loop and a do while loop, and don't forget to put a semicolon at the end of like this one. This is kind of the exception to the rule. You'll never put a semicolon behind any other while or for loop. Only in this case will you do that. The advantage to doing a do while loop is that you don't actually have to have kind of this priming around. What a do while loop does is your pointer comes along, enters the do while loop without even thinking, and basically it executes whatever's inside, and then it hits the while, and if the statement in here is true, then it jumps up here and does it again, and it keeps going around until this is false and then leaves. So it's kind of like a different way of writing a while loop. It's just slightly more compact. So I don't even know why we're doing the names still. I'm just gonna do a bunch of names. Wait, was that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 10. Now, what I can do is say as many characters as I want, and the only way we'll ever leave this loop is if I enter 0. And once I enter 0, the flag goes off, and then, yeah, this gets turned off. I mean, that's one way of doing a flag loop. Another way is actually having like kind of a bool value inside. So I mean, we would have like a if inside. Like again, this is a very bare bones way of doing this. You wouldn't do anything like this in real life. There'll always be kind of like a more in-depth in-depth way of doing it, and kind of a different way of looking at it, but for practice, this is good enough. So truth equal to false. Okay, and for this, we're just going to have to initialize truth to true. That's what truth equals. Truth is equal to true until we enter a 0. In that case, the flag gets tripped, and then we exit the loop. That's how a kind of like a flag-controlled loop works. I'm not going to show it to you guys again because it's exactly how I did it before. I just moved it over into an if. But that is loops. I'd say definitely practice them. It's all by taste. But I would definitely, out of the 3, recommend that you practice the for loops, for count controlled, and the while loops. You can get away without really knowing the do while loops, but I mean, if you really want to learn them, go for it. They'll make your code more compact, a little bit more efficient, because you won't have to be writing these primer lines. But yeah, just experiment with that. Use the bools that we went over a couple videos ago, and just learn how these things work. Be very careful because you can actually nest these loops. When I say nesting, is you can put a loop within a loop, kind of loopception. So we can take this and we can put it here, except be careful that you use a different value. So use J. Typically what this kind of setup would be used for is if you had a 2-dimensional array. I think I've got a little extra time, so I'll just quickly touch on that. A 2-dimensional array is pretty much exactly like a 1-dimensional array, except you can add like a second block here. So in this case, there's going to be 10 rows and 10 columns. So there's going to be 100 different names in all. And you'll be careful with C++ or Visual Studios because it will get a little finicky. Okay. Whenever you use a 2-dimensional array like so, or more dimensions, like you can add as many dimensions as you want. You have to specify which place in the whatever dimension array it is. So I'm using I to track the rows, J to track the columns. So I'd start at 0, 0. And what would happen is I would iterate this inner loop until this becomes false. And then I go along my merry way, increment this, and then do this again. J would be set down to true, and would do this again. So essentially, this gets iterated 100 times, one for each member in the array. So just keep that in mind as things grow, because, well, this is an absurdly large number, and just imagine, yeah, the array is too large, because the computer can only take so much. Yeah, the computer can only take so much. I mean, look at this. Oops, I erased the wrong thing. But yeah, again, see, it's way too large. And just keep in mind, the more elements, or the more rows and columns you put in, the longer it'll take your program to iterate. So I mean, if you set this all up so it automatically read from a file, if you increase kind of an array, whatever dimension it is, but it's more noticeable with multiple dimensions. If you do that, the program will take a lot longer to iterate. And you just got to keep that in mind, especially if you plan to go further than this just intro tutorial. Like if you plan to be taking more advanced courses, or if you plan on actually programming for companies, you do have to keep runtime in mind. I mean, just think of it. How many watching get so frustrated when your computer takes forever to load something or to boot up? Well, that's just essentially just how much data is being set into the thing. There's also a host of other issues that'll slow things down or speed things up, but the onus is on the programmer to write the most efficient code possible, so that's the only thing slowing the computer down is the hardware. So once we come up with magical technology that speeds everything up to instant whatever, then everything can be super quick and instant because we'll have the most efficient programs. And essentially, that's kind of the trade-off. You can do one of two things. You could speed up your hardware, or you can make your programs more efficient. Since getting better hardware is a lot more expensive, it's kind of hard because you got to keep up with everything and stuff breaks, fades over time. Having an efficient code is the best thing for any programmer to do. It just makes everybody way more happy because the computer runs very fast, and just your program probably won't be like billions of lines long. Just write very efficient code, use loops, understand kind of how everything works, and the way to do that is to practice. Sit down, write some code. Even if you don't have like these programs, these compilers, sit down. I mean, you could even write it out on a piece of paper and ask somebody to check your work. Kind of like a proofreading if you've been writing a paper. Ask someone who knows what they're doing to kind of proofread your program. If you don't have anyone who knows how to program close to you, then what you can do is you can go online. You can put up your program on forums. Just tell everyone you're learning how to program and just ask them to check for errors. I'm pretty sure programmers will be very nice. They'll see that you're a beginner and they'll check it for you. But I think that's all I've got for this week. Until next time, I'll be seeing you.